Continuing with 1.4 of Pre-Cal 40S, R5R6, and we are talking about inverse functions. So in this question here, it asks us to sketch the graph of f of x equals x squared minus 1. And if you notice, this is our parent function of x squared shifted down 1 unit. So instead of having our vertex here, our vertex is going to move down 1 unit, and then every corresponding point is going to move down 1 unit, just like that. Okay? I'm just going to go through our points there. All right, so this is our graph of f of x, and what question is asked here is, will the inverse of this be a function? All right, so without trying to graph it or do anything, we can just look at the original function and run the horizontal line test. So we'll run the horizontal line test on the original graph, and it crosses through, it hits the graph in 2 spots, which means that it is not going to be a function. So the horizontal line test fails. Therefore, the inverse will not be a function. Okay, so now if we use the graph of f of x, we are going to sketch the inverse of f of x. So let's use that right here, do that right here. So we'll take these points and we will switch the x's and y's. So I'll do that in pencil so you can see the difference. So this 0, 1 is going to end up going right here. And this 1, 0 is going to be 0, 1. So that's going to be right here. And this point, which was originally -1, 0, is going to go to 0, -1. So that's right there. And our -2, 3 is going to be 3, -2. And this one here, which was 2, 3, is going to be 3, 2. So this in pencil is my inverse relation. It's my inverse of the original f of x minus 1. So this here is f inverse of x. All right. Now, if we ran the vertical line test on our graphed inverse, we can see that it fails the vertical line test. So horizontal line test on the original fails, and the vertical line test on the inverse fails. So it's kind of the same thing, but you can do either one. Now here, in part C, it says, explain how we can restrict the domain of the original graph so that the inverse is a function. Now the key here is restrict the domain of the original graph. So that means which part of the original graph are we going to take away or chop off or get rid of or not allow, which x values of the original are not allowed, okay, in order for us to have the inverse be a function. So if you look here at what we've drawn of the inverse, if we were to cover up the bottom half of this graph, now it is a function because you only have this top part here. So this is from where x is greater than 1. X is greater than -1. Or you could also have this. So now if we chop off part of it, it's going to be, our inverse is going to be a function. So the question asks, what part of the original graph needs to be removed so that we can have the inverse be a function. Okay, so if we're looking at the original, well, then that's basically either half of it this way or half of it this way. So we'll look at the domain of the original. So again, of the original it's talking about. It could either be x is greater than or equal to 0. Okay, so if we do that where x is greater than or equal to 0, then that's talking about this right here. And the inverse of this is going to look like this top part here. We could draw that over here, and it's going to end up looking like right here, here, and here. So that's when the original is restricted to x is greater than or equal to 0. Okay? But just make sure that you know that this is the graph of the inverse here. All right, so now we can say that f inverse of x is a function. It passes the vertical line test. Okay? So we just took the right-hand side of the vertex in order to do that. So is there another possible answer that you can give? Well, sure there is. We could cut off the other side. So we could restrict it on the opposite side, and then we will have the same idea, but our inverse is going to look a little different. So if we restrict it like this, so we have this, we end up with the top part. And if we restrict it on this side, where x is less than 0, less than or equal to 0, we're going to end up having this bottom part be our inverse. So let's do that. So x could either be less than or equal to 0 of the original graph. Okay, and you could kind of do a simple little sketch here where it goes up like that, and then so this is f of x, and then f inverse of x would be that. So that's the left hand side of the vertex. Okay, so write the equation of the inverse relation. So depending on which one we have, so we've got our f of x is equal to x squared minus 1. The inverse, if you recall how to show the inverse, well, if you just notice that this is going to be the square root function over here, and that's the negative side. This over here is going to be our square root function, and it's the positive side. So the inverse of this is going to either be plus or minus the square root of x plus 1. So decide on which one actually fits the answer that you're given. So we could look at this as the square root function shifted over 1 unit to the left, or we could also do it algebraically just like we did before and show this. So y equals x squared minus 1, and then switch our x and our y's, and then solve for y. So we're going to have x plus 1 equals y squared, and then take the square root of both sides. So we have the square root of x plus 1, and that equals y. Remember, we've got our plus and minus there. And now to change the y to our f inverse of x. And that's plus or minus x plus 1. Make sure you decide which one is which. So over here, this one is going to be our negative, and the one up here is going to be our positive. Okay, so we got that there. That fits that one, and this -1 fits that one. Okay, let's go on to proving that functions are inverses of each other. So it's difficult to prove that two functions are inverses of each other graphically. To prove, when we say prove, what we want to do is we want to see algebraically. We're going to look at this. F of x is the inverse of g of x. Therefore, this must hold true. F of g of x will be equal to x. So basically, when we put the inverse inside of the original equation, substitute the x value with the original, from the original equation, we're going to end up with x as our answer. So substitute x into g of x, and then we substitute the result into f of x. So let's run through this and have a look at what's going on. You could do it either way. Either way, you should end up with x at the end of it. So for this, we're going to show that f of x equals 3x minus 5 and g of x equals x plus 5 all over 3 are inverses of each other. So what we're hoping to see is this. At the end, we are going to get this, hopefully. Okay? Let's actually do that now. So g of x, what is g of x? G of x in this case is x plus 5. So instead of this, in my next step, I'm going to put x plus 5 over 3. And let's see what I end up with when I make that substitution. So I have my 3, and then I'm going to leave a big bracket there, because what I'm going to do is I'm going to substitute that in there. So I've got f of x plus 5 over 3, and then 3, and my bracket, x plus 5 over 3 minus 5. And then I'm going to just simplify things. My 3's reduce. I end up with x plus 5 minus 5, x plus 5 minus 5. Simplify that, 0 equals x. So then here I get, since f of g of x is equal to x, I have f of x and g of x are inverses of each other. All right. Now on the next page there are 3 examples, or 3 questions where you can practice this. I want you to hit pause and try those on your own, and then I'll show you the answers. Okay, so for these questions here, we've got f of x being x minus 4 and g of x is x plus 4. So are these inverses of each other? Well, what we have to do is we have to show that f of g of x is equal to x. So the steps to run through that are, we're going to put our x plus 4 in a place here and substitute that in the original f of x. Okay? Once we do that, simplify what we have and we end up with x. So they are inverses of each other. Now the second one is we've got our g of x, which is here, goes in this place. Okay, and then wherever our x was in our f of x, that's where we have our g of x in there. Okay, and then we simplify that and we end up with f of g of x is equal to x. And the last one is just exactly the same. So whatever g of x was, that goes in place of our x here. So that goes there. And then we simplify what we have on our right hand side and we end up with x, and that's the result we want. Alright, so that concludes it. That's the end of our video, and that's the end of chapter 1. So congratulations.